Hey everyone, Linus here. Today we're diving into the world of computer networks to unravel the mystery of ARP, or Address Resolution Protocol. Don't worry, it's not as complicated as it sounds. Think of ARP as the postal service of the internet, responsible for delivering your data packets to the right destination. In simple terms, ARP helps your computer find the MAC address of another device on the same network. You see, every device on a network has a unique IP address, like a street address, and a MAC address, which is like a unique fingerprint. While IP addresses are used for routing data across the internet, MAC addresses are used for communication within a local network. ARP comes into play when your computer needs to send data to another device but only knows its IP address. It's like knowing where your friend lives but not their phone number. ARP acts as the directory, mapping the IP address to the corresponding MAC address so your data can reach its intended recipient. Now you might be wondering why we even need ARP in the first place. Why can't our computers just use IP addresses for everything? Well, it all boils down to how networks are structured. At the network layer, where IP addresses reign supreme, data is routed across different networks and subnets. However, when it comes to the actual transmission of data packets, we need to operate at the data link layer, where MAC addresses are used. ARP acts as the crucial bridge between these two layers. It allows devices on the same network to communicate directly using MAC addresses, which is much faster and more efficient than relying solely on IP addresses. Without ARP, our computers would be stuck in an endless loop of trying to find each other, leading to slow and unreliable network performance. Let's break down how ARP works with a real-world example. Imagine you're sending an email to your friend. Your computer knows your friend's email address, which is associated with their IP address. But to deliver the email, your computer needs to find their MAC address. First, your computer sends out an ARP request, like a shout-out, to all devices on the network asking, "Hey, who has this IP address?" Then the device with the matching IP address responds with an ARP reply saying, "That's me, here's my MAC address." Your computer stores this information in its ARP cache like a little address book for future reference. Now that your computer knows the MAC address, it can finally send the email directly to your friend's device. This entire process happens behind the scenes in milliseconds, ensuring seamless communication between devices on your network. Section 4. Visualizing ARP diagrams and examples. To better understand ARP, let's visualize it with a simple network diagram. Imagine 3 computers connected to a router. Computer A wants to send data to Computer C but only knows its IP address. Computer A sends an ARP request to the broadcast address, reaching all devices on the network. Computer C, recognizing its IP address in the request, sends back an ARP reply with its MAC address. Computer A receives the reply, updates its ARP cache, and sends the data directly to Computer C using its MAC address. This example illustrates how ARP enables efficient communication within a local network by resolving IP addresses to MAC addresses. Section 5. ARP in the real world, everyday applications. ARP is a fundamental protocol that plays a vital role in numerous networking applications we use every day. Here are a few examples. Web browsing. When you type in a website address, your computer uses ARP to find the MAC address of your router, which then connects you to the internet. Online gaming. ARP ensures smooth and lag-free gaming experiences by enabling direct communication between your computer and the game server. Streaming services. Whether you're watching Netflix or listening to Spotify, ARP is working behind the scenes to deliver the media content to your device. In essence, anytime you're accessing the internet or using a network-connected device, ARP is quietly working its magic to ensure seamless connectivity.